All right, welcome calculus students to part 2 of section 4.5, which is on U substitution. We went through the power rule for U substitution in the previous video, and now we want to look at the trig rule, which is the second major rule for U substitution. And for the trig rule, what we're going to have is we're going to look at the form of some trig function, sine, cosine, could even be like secant squared of U du, and that's the form. So the u is actually, unlike the power rule where the u is inside parentheses to some exponent, the trig rule is the u is inside a trig function. All right, so let's do an example. So let's say I have the antiderivative of cosine of 5x dx. So this isn't something we've been able to do before because we have this cosine of 5x here, and we were able to do cosine of x, so I know that the integral or the antiderivative of cosine of x is sine of x plus c, but now I've got this 5x term in here. So the form that we're looking at, that we want to solve for, is, and always think about your forms for u substitution. So my form is going to be the antiderivative of cosine of u du, and this I know how to integrate. So the antiderivative of cosine of u du is going to be equal to sine of u plus c. And so I need to make this substitution. So I'm going to go back to my antiderivative, and so my u is going to be what's inside the cosine, so that's 5x. So I'm going to let my u, be equal to 5x. And if I do that, then this first term becomes cosine of u. So I've got part of the substitution done, but remember we have to substitute for what's left over, and what's left over here is this dx. So I'm going to lock it up, and I'm going to differentiate u. So du is equal to 5 dx. And remember, box what you're locking up that you need the substitution for. So dx is equal to 1/5 du, because I solved for dx. So this dx up here in the original problem is 1/5 du. Okay, so I'm going to rewrite the antiderivative in terms of u, and I'm going to bring that 1/5 out front, because you can always pull constants out front. So I've got 1/5 the antiderivative of cosine of u du. And so now I just differentiate with respect to u. So, now I just integrate with respect to u. So I've got 1/5, and then the antiderivative of cosine of u, as we know, is sine of u plus c. And then the last piece that I want to do here is I want to put my u back in. So this is 1/5 sine of u was 5x plus c. And if you want to prove that this is correct, again, just take the derivative and make sure you get cosine of 5x, which is the original integrand, which you will. And this is a pretty easy one to prove. All right, so next we want to look at a little more challenging example. So let's say, for example, I've got the antiderivative of x squared times secant squared of x cubed dx. And I'm going to write this in a little bit different form. So I've got the antiderivative of secant squared of x cubed times x squared dx. And we'll see why we're doing that in a moment. Okay, so first you have to ask yourself, what form do I have? Now, don't get confused by this square on the secant, because the antiderivative of secant squared, as we know, is tangent. So over here I'm going to look at what form I'm looking for. So the form of this u substitution is going to be the antiderivative of secant squared of u du, which is going to be equal to tangent of u plus c. So I don't use power rule in this case because the squared on the secant is actually we know what the antiderivative is. It's tangent. Okay, so let's go back over here, and I'm going to let u be what's inside the trig function, which is x cubed. So that gives me what I'm looking for. So I'm looking for secant squared of u. But like all these u substitution problems, I need to figure out what x squared dx is in terms of du. So I'm going to differentiate u. So du is equal to 3x squared dx. And I'm going to lock up what I need to sub and solve for it. And so this quantity x dx that I still need to substitute is 1/3 du if I solve for it. So this blue box is going to be 1/3 du. Okay, so now it becomes a relatively easy problem. So I'm going to pull out that 1/3. So I've got 1/3 the antiderivative of secant squared of u du, which is going to be equal to 1/3. And then the antiderivative of secant squared of u is tangent of u plus c. And then the last step that I need to do here is just put my u back in. So the antiderivative is 1/3 tangent of u, and u was x cubed plus c. And that's it. All right, next one. Let's do another one. Again, it's just going to look a little more tricky than the other ones. So, for example, let's say I have the integral of sine of the square root of x over the square root of x dx. Now, when you see something like this, and the sign's not to a power, we know we want to use this trig rule, because we still want to get this in the form of the antiderivative of sine of u du, which I know is minus cosine of u plus c. So I know how to integrate sine of u. And so, so I just need to rearrange this a little bit so I can see that. So I'm going to write this as the antiderivative of sine of the square root of x, and then I'm going to multiply that by 1 over the square root of x dx. So all I did is I shifted this 1 over square root of x away from the sine and multiplying it by the dx. Okay, so now I can do my u substitution. And so I'm going to let u be equal to what's inside the trig function, which is the square root of x. And so this becomes sine of u, which is what I'm looking for. And then what's left over to sub is this 1 over the square root of x dx. And so, like always, what we do is I'm going to differentiate u with respect to x. So du is equal to, now the derivative of the square root of x, as we know, is 1 over 2 square root of x dx. And remember, you want to lock up this 1 over square root of x dx. So I'm going to lock this up, and this is actually a 1/2. And then I'm going to multiply both sides by 2. And so my 1 over the square root of x dx, which is what I need to sub for, is going to be equal to 2 du. So this whole box is 2 times du. Okay, so now I can do this relatively easily. So I'm going to pull the 2 out. So I've got 2 times the antiderivative of sine of u du, which is going to be 2 times the antiderivative of sine of u is minus cosine of u, and then that's plus c. And then the very last step, of course, is to put your u back in terms of x. So I've got minus 2 cosine of the square root of x plus c. And you can prove that this is correct if you take the derivative, and you should get the original integrand. Okay, the next thing to do is actually look at situations where you have what looks like where you might want to use the trig rule, but you always want to use the power rule. So let me show you. So this is the power rule. For trig functions. And you'll want to use this whenever you have a trig function to some power, except for that secant squared or the cosecant squared, because we know what the antiderivative is. So basically remember that the power rule is the integral of u to the n du is equal to u to the n plus 1 over n plus 1 plus c. But here we're going to be dealing with trig functions. So let me just kind of show you by looking at a relatively simple example. All right, so let's say I want to take the antiderivative of sine of pi x to the 5th power times cosine of pi x dx. Okay, so the reason this is a little confusing at first is because we just learned the trig rule, so you'd think that the u should be pi x, but the u is not pi x. And the reason for that is that the power rule really takes precedence here. And you don't want to use the trig rule at all. You only want to use the trig rule if you have a trig function that's not to a power, and this is to a power in this case, except for secant squared and cosecant squared. So really what I have here is I have a u to the 5th power. And so whenever you see something like this, where there are things inside of these trig functions, but there's also one of the trig functions to a power, you have to use the power rule, not the trig rule. Because the form that we're looking for here, the form is going to be the antiderivative of u to the 5th du, which we know is u to the 6 over 6 plus c. That's the dominant form in this equation. So to get there, I'm going to rewrite this. So I've got the antiderivative of the quantity sine of pi x to the 5th power times cosine of pi x dx. Okay, so what I got here is I want to let u be equal to sine of pi x. And so what that enables me to do is that this whole term is u to the 5th. Now notice I'm not using the trig rule because one of the trig functions is to a power. And so the power rule takes precedent. So here, now the next step as always, is I've got to substitute cosine of pi x dx. Okay, so I differentiate u with respect to x, so du is equal to the derivative, and here's one of the problems with u substitution, is you're integrating, but you have to take the derivative to find your du. So with more complicated problems, it's really important that you write down everything, because it's easy to kind of get mixed up between whether you're integrating or differentiating. So when you're doing u substitution, you first find your u, and then you differentiate that u. And so du, so the derivative of cosine, remember, is going to be, the derivative of sine, so we're taking, so u is equal to sine pi of x. The derivative of sine of pi x is going to be pi times cosine of pi x dx. And if I look at the original problem, what I need to lock up, what I still need to sub, is this cosine of pi x dx. So my cosine of pi x dx, which is what I need to sub, and I've locked up, is equal to, in order to solve for this box, I need to divide both sides by pi. So this is equal to 1 over pi du. So this blue box is 1 over pi du. So now I can put this back into my equation. I'm going to factor out that 1 over pi because it's a constant. So I get 1 over pi times the integral of u to the 5th du. Now stop and look at this for a moment. All I'm really doing is using the power rule. I just have trig functions. And don't concern yourself with what's inside here at first, because what happens is once you, for the types of problems that you will see, once you get this and you take the derivative, what's inside is taken into account. So really what this problem is, and don't lose focus of it, is just some u to the 5th du. And so then the solution, once you get down to this point, is relatively easy. So this is equal to 1 over pi times the antiderivative of u to the 5th, which is u to the 6 over 6 plus c. And then the last piece is I need to substitute my u as a function of x back in. So I get sine of pi x to the 6th power over 6 plus c. And again, you can prove this is correct by taking the derivative and putting it back into, taking the derivative and comparing it to the original integrand. All right, one more. I'm trying to put trickier ones on here to kind of help you in the long run. So let's say look at the antiderivative of the square root of tangent of 3x times secant squared of 3x dx. Okay, so when you look at this, again, we're looking for what form we want to use. Now, if this square root wasn't here, now if the square root was not here, I could just use the trig rule, not a problem. But because the square root is here, this tangent is to a power. And so I'm going to rewrite this. as this is equal to the antiderivative of tangent to the 3x to the 1/2 power times secant squared of 3x dx. And I need to figure out what form I'm looking for here. So the form that I'm looking at is actually the antiderivative of u to the 1/2 du. Okay, so let's see if this works. So I'm going to let u be equal to what's inside my power, which is going to be tangent of 3x. So that makes this whole thing u to the 1/2. Okay, so far so good. But always with the u substitution, I have to make substitutions for all x values. So I'm going to differentiate u to do that. So du is going to be equal to, now no, actually this doesn't work. Okay, sorry. So let's see. So here in this case, du, tangent of 3x, is going to be equal to, if I take the derivative of tangent of 3x, is going to be 3 times secant squared of 3x dx. So what I'm going to do is I'm going to lock up what I need to substitute. And so what I need to substitute is 1/3 du. So this whole term is 1/3 du. Okay, so what I'm going to do is I'm going to rewrite this. So I'm going to pull out the 1/3. So I've got 1/3 times the antiderivative of u to the 1/2 du, which is going to be equal to 1/3, and the antiderivative of u to the 1/2 is u to the 3/2 over 3/2 plus c. So this is going to be equal to 2/9 u to the 3/2 plus c, and I put my put my u back in. So the antiderivative here is 2/9 times, I'm going to write it like this, tangent of 3x all to the 3/2 power plus c. All right, cool. And then all you need to do is, if you want to check it, is take the derivative and make sure you got the original integrand. All right, cool. So there's one more video, and that is it. So I'll see you then.